All right, we're going to look at some inverse trig functions. Um, the top part here with this box and this graph was kind of an exploration, kind of an introduction. So I'm going to go through it pretty quickly, but it says to use your unit circle to evaluate the following. We have sine of 7 pi over 6. So on our unit circle, we would find that angle. So I'm going to grab mine. 7 pi over 6, we'll go down here, is this one. And if I want sine of that angle, I want the y value of my point, so negative 1/2. And I would do that for all of them. But if we have something that is too small, like this one, or too large, like this one, we have to fix it by adding 2 pi or by subtracting 2 pi until we get an angle that's on the unit circle, and then we can find all those values. You can pause this video and find those, because I'm going to write the answers down in about 2 seconds. All right, so sine of negative pi over 6 is negative 1/2. Sine of 11 pi over 6 is also negative 1/2. And then the last one is also 1/2. So when it says to plot the points on the graph below, this is our sine curve because we know it starts in the origin and the period ends at 2 pi. And since these are all asking for a sine of different angles, we can plot these on our graph. To do that, the angle ends up being our x, and then our answer ends up being our y for the point that we're graphing. So 7 pi over 6 is a little bit past 1 pi. So 1 pi is here, a little bit past it, and then my y value is negative 0.5. So this point would be 7 pi over 6, comma, negative 1/2. And then I'm going to do it for all of them. So negative pi over 6 is going to end up being this one. $11 pi over 6 is here, and then 19 pi over 6 is there. And I'm not going to label those. But we also know that with sine curves, they continue to go on forever. And so we could have even more than this that have an answer of negative 1/2, like this one, and then so on and so forth. Excuse me. So we're going to go down the page a little bit. So it says, what does it mean to have an inverse function? So inverse functions are our way of working backwards. So normally, when we are given a trigonometric function such as sine, cosine, or tangent, I would ask you to plug in your input, or that would be your x value. And then you would be able to tell me your output or your y value. And that's what we did very briefly at the top. So inverse functions, we have 3 of them to go with the 3 trigonometric functions. We have the inverse of sine, which looks like that. We also have the inverse of cosine and the inverse of tangent. We can tell they are the inverse functions because of that negative 1 exponent. But the weird part about this is how they're pronounced. This right here for the inverse of sine is pronounced arcsine, arccosine, and arctangent. So we do want to become comfortable with both notations because I could use the notation with the negative 1 exponents, still pronounced as arcsine, arccosine, or arctangent, or I could write it out like this and have it written out for you. They are the same. So whether you see this notation or this notation, they are asking the same thing, which basically means if I ask you to find arcsine of negative 1/2, what that means is where on your unit circle, so at what angle, does sine of that angle equal negative 1/2? So we're kind of going backwards to what we did at the beginning. So if I grab my unit circle, sine are the y values. So I look at all my y values around the unit circle, and I want negative 1/2. So I kind of keep going around. I'll scoot it up a little bit. I see negative 1/2 right here, and it's in the y spot, which means sine. So I know 7 pi over 6 would be an answer. So I'm going to write that down. I didn't continue around my entire unit circle, so I'm going to keep going. So we're looking at our y values, and I have another y value of negative 1/2. So this angle, 11 pi over 6, would also be able to answer that question. So at the top, we did it backwards. I'm going to do it in a different color. We said, like, find sine of 7 pi over 6. Well, that ended up equaling negative 1/2. And so now, if I ask for arc sine of negative 1/2, I'm trying to figure out what that angle is. And there's 2 of them on our unit circle that fulfill that. Now, there are more, technically, if we think of coterminal angles like we did at the top of this page, but for now, we can just see that there's multiple. We're going to go ahead and flip our page. So since we were talking about inverse functions, we do have to make sure that it is still a function for it to work. And all functions we know can only have one output for every input, which means it has to be 1-to-1. So that means for every y value, it must come from only one x value, or every x value has only one y value. And so that is not the case when we found arc sine of negative 1/2, because it came from multiple angles. It came from 7 pi over 6 and 11 pi over 6 on our unit circle. So as of right now, we have 2 outputs for our question. It's not a function. So to create it, or to force it to be a function, to be an inverse function, we have to restrict our unit circle and only look at half of it, and that way we would only get one angle and not multiple. So for our regular sine function, we cannot have an inverse function unless we restrict our unit circle. And then we're going to specify how we're going to do that underneath. So a couple reminders: if we're finding sine of an angle, that is the y value of the terminal point. This is back from first semester. Cosine of an angle is the x value of a terminal point. And then tangent of an angle, if you look at your unit circle, the tangent values are all of the values on the outer edge. So I'm just going to say, like, the outside number. And that's just there to kind of remind us as we go forward. So in the very bottom table, we have a pretty large space here that says important ideas. So we're going to specify what part of the unit circle we're looking at for each of our inverse trig functions. So at the top, we're going to specify what an inverse is. An inverse is when we take our inputs and our outputs, our x values and our y values, and we kind of flip them compared to our normal original trigonometric functions. So we're going to say the input of y equals sine of x ends up becoming the output, I know how to spell, of y equals arc sine of x. So if I ask for sine of some angle, that angle is your input. But for arc sine, I would be asking for arc sine of 1/2 or square root of 3 over 2, or negative square root of 2 over 2, and my output ends up being the angle that has that on the unit circle and the y value. So with our regular trig functions and our inverse, our inputs and outputs kind of switch. So we're going to make 3 columns here because we have 3 inverse trig functions. So on the left, we're going to start with arcsine, and we're going to write down both ways that you could see it. Both of them are pronounced as arcsine, so y equals arcsine of x and y equals arcsine of x. Our domain for arcsine goes -1 to +1 with those values included. And then I'm going to wait to fill in the range until we talk about what part of the unit circle we are restricting. So I'm going to grab my unit circle here, so I'm going to cover up the notes for a second. If we look at this larger one, for arcsine, we're looking at the y values. All of these y values here are positive, and if I continue around my circle, I'll notice that this y value is a repeat of this y value. Square root of 2 over 2 is a repeat of square root of 2 over 2. Positive 1/2 is a repeat of positive 1/2. And so it doesn't make sense to have both of these quadrants, because then we would have repeated values, and that is not a function. So we have to get rid of one of these quadrants. So in class, we kind of had a larger discussion about what quadrants we're restricting it to. In here, though, we don't have time for that. So for arcsine, we are focusing on just the right side of our unit circle. So this is how I kind of visualize it. Whatever helps you to visualize it, I want you to kind of sketch that. And because we're restricting it to the right side, normally we start at 0 and we would go all the way around. But if we're stopping here and we're not using this left side, we can't continue going around the circle. And so while this angle is pi over 2, the angle at the bottom here is normally 3 pi over 2. But that is when we go around in a circle, and so we know that this angle could be written as negative pi over 2. And so those values are the values that our range is in between. So our range goes from negative pi over 2 up to pi over 2, and those values are included. You will not have to memorize the domain and the range specifically for this, but you will have to know for arcsine, you're looking at the right side of the unit circle, and the other two might be different. So you are going to have to know the difference for that. So the middle one, we have arc cosine, so we're going to denote both versions of that. And then we're going to do our domain and range. So our domain ends up being the same as arcsine, and our range we will get to. So for arc cosine, it's a little different. We can't restrict it to the right side of our unit circle because the right side, the cosine values are duplicates, and so we can't have the same as this one. So for arc cosine, we are actually going to restrict it to the top part of our unit circle. So we're going to go from 0, and then if we go halfway around, this angle ends up being pi. And that's nice because I can continue it in order, and it's just 0 to pi. So my range ends up being 0 to pi with those values included. So for arc cosine, we're looking at the top. For the last one, we have both versions of our tangent that we're going to include. Our domain for arctangent is all real numbers, and our range we'll include in a second. So for this one, it was a little tricky, so I'm going to grab my unit circle because I do want to explain this a little bit. For tangent, we're looking at the outer values, so I want to look and see when are they duplicates. So quadrant 1, they're all positive, and if I go to quadrant 2, they're negative. If I go to quadrant 4, they're negative. And so it looks like I could do either the right side or the top, but that is not the case. If I go across the top, this tangent value that is undefined is almost like a hole in our graph. And so I can't go past that undefined mark to include quadrant 1 and quadrant 2. So because it's undefined here, it is forcing me to go down to quadrant 4. So for arctangent, we're focusing on the right side, which matches arcsine. And since the values at pi over 2 and at negative pi over 2 are undefined, those values cannot be included in your range. So that's why I left them as open circles. And then in our range notation, we're going to say negative pi over 2 up to pi over 2. And I don't have those lines underneath because since they're undefined, they cannot be part of that solution set. They can't be part of that range. So arcsine and arctangent, we look at the right. Arccosine, we look at the top. This is where I'm going to stop this video, and then I'll have a part 2 that goes through some examples.